Good day, this is Jim Pytel from Columbia Gorge Community College, EET 122, Digital 2, part of the Renewable Energy Technology Program. Okay, today we're going to discuss encoders. So encoders are just like decoders in opposite land. So if you remember, a decoder detects the presence of a specific combo of bits, i.e. the code, and it indicates its presence by a specified output. Well, the encoder does the exact same thing in reverse. Given a specified output, it gives you a specific combo of bits. In its most basic form, just think of a box. Let's just do, I don't know, 10 inputs, and there's 4 outputs there. And just say this is a decimal input, 0 to 9. And here's our low order bit, intermediate bits, high order bits, MSB, LSB. You go ahead and press a 5 key. And there it goes, and what you're going to get out is 0, 1, 0, 1, which is the BCD output for 5. So what we've done is just created a decimal to BCD encoder. Okay, so key thing about this thing is only one key can be pressed at a time. Okay, we're going to go into priority in a little bit here. But so just go back to this guy here, this decimal to BCD encoder. Just think about, you've got a 0 key, right here, and it's pressed. Oh, I don't know what that happened. A 0 key is pressed. What's our outputs going to be? Well, it's going to be 4 zeros there. You press the 4 key. That's what's the output's going to be. Press the 9 key, and on and on and on. 0 to 9. So anytime you press one key, one specified input, you get a specific combo of bits on the output. That's what an encoder is. Okay, so priority. So the problem with encoders is you got a bunch of inputs here. See all these inputs. Which one is it going to represent if, let's say, the 6 and the 7 key are pressed simultaneously? Well, we don't know unless you've established some priority. So, basically 6, you would expect a 0, 1, 1, 0, a 7, 0, 1, 1, 0. Which one's it going to be if they're pressed simultaneously? Well, the answer is this guy, the highest priority. If you could think of it this way, here's the door to the chow hall. And coming around this corner, and coming around that corner, here's PFC, Schmedlap, and here's 5-star general, a bunch of stars, Hawk coming around the corner, and they're both going to go through the door at the same time. Who do you think is going to get through it first? General Hawk here. Okay, so highest order receives precedence. So in our example where the 6 and 7 key were pressed simultaneously, 7's going to get the output. 0, 1, 1, 0, 1, 1, 1. Okay, so let's talk about the 74, 147. Unfortunately, active low output and active low input. So if you think, here's our inputs, and here's 1 through 9, and I'll explain why there's no 0. And then you've got active low outputs right here for our high order bits, then going down to our LSB. So what this is implying is this guy, let's say we want to have a 2 come out here. That needs to go to 0 volts. Otherwise, it's assuming that there's no input. Okay, so what's going to happen is, well, since these are active low outputs, and swing these guys down here so they make a little bit more sense. What's the MSB going to be? Well, it's 1, 1, 0, 1, which is the complement of 2. Because ordinarily, 2 looks like that in a 4-bit binary world. What it's producing is the complement of 2 for its output. So active low output, active low input, and the fact that it's got to get a 0 volts for it. So why is there no 0 in? Well, there is no 0 input because no input gives all highs on the output. I'll go ahead and reduce all these inputs there. It's going to give all highs on the outputs, which, if you remember right, that is the complement of 0. Okay? So how do we produce an active low in? Well, what you would do is just say, here's the 3 key. What I would do is I'd put a pull-up resistor, put that to +5, and let's just say it is a key, it's a keyboard that we're working with here. And what I would do is I'd have this little switch in between it and ground. So once I press on this key, it's going to move down and make that connection to ground, which is not going to do us anything because I need to put it over here. So now here's my switch for, here's my keyboard. You know, this is my big key that says 3 on it. My big fat finger comes down and presses it, and what it's going to do, it's going to click that there, and that's going to be now 0 volts. Because remember, our pull-up resistor previously was at +5, but now that that is grounded, that's our 0 volts. And it's going to give me an output for a 3, which, what is, if it's active low, what is, what's it going to look like here? And that's my complement of 3, so 3 would ordinarily